Hi everyone. Today we're going to look at the third part of our transformer series that we have done. So in the first part, we have seen how to fine tune a transformer model like a BERT on your custom dataset. And then once we have a fine tuned transformer model, how to deploy that model as a streamlit application on a streamlit cloud. Now today, what we're going to do, we're going to deploy that same transformer application or a same transformer model which is integrated inside the Streamlit application on AWS Fargate. So what is AWS Fargate? AWS Fargate is a serverless computing for containers. So we can take our application, which is here. We have seen it in the last video. We can take this application, containerize it as a Docker image, and then deploy it on AWS Fargate. Since it is serverless compute, we don't need to worry about provisioning individual EC2 instances or even scaling, downscaling, or upscaling as per the traffic. That all taken care by AWS Fargate. We just need to tell AWS Fargate this is our Docker image, and we want to, these are the resources, let's say a RAM or a CPU that we want to provide, and all things will be taken care by AWS Fargate in terms of scaling those resources or downscaling and all these things. So let's look at our application, that what we have seen it already, right? This particular Streamlit application we have deployed on a Streamlit cloud. So currently I have ran the same application locally here, Streamlit run command, and then the name of the file where our application is here. This was the app we have seen already in the past video. So if you haven't seen, I recommend you go to this particular playlist on my channel and watch these two videos. So this was a toxic comment classification. That's what we fine tune our BERT model. So if I put let's say this is the comment, and go to help, then it will analyze and says that it's a toxic comment. And if I say that that was a good point, then it says that it's a non-toxic comment. Now what we want to do, we want to take that same Streamlit application and deploy it as a Docker container on AWS Fargate. So I note down what are the steps that we need to do. So we can think of this deployment has a two parts. One is building the Docker image and test that image locally, just like we have ran a Streamlit application here. We could run the same Streamlit application using a Docker image. So you will also learn how to create a Docker image for your application. And the next part will be creating a Fargate application using that Docker image. So the steps will be something like this. First, build Docker image and test it locally. Then create a ECR repository. Once we have an image, we need to store that image somewhere on AWS. For that, Amazon or AWS provide a Amazon Elastic Container Registry. This is where we can share our images, or we can upload those images here. And from this registry, our Fargate application can pick up that particular image. So that is the step to create and push our image to that ECR repository. Then we need to create a cluster. Now here, creating cluster is just simple thing that you just go click on a create cluster. We don't need to worry about any configuration aspect of it. And then to run our Docker images on this cluster, we need to create the task. Now task is the thing where we specify a cluster. This is the image. Let's say this particular image that we're going to create, we want to run it. Let's say we want to allocate 2 GB RAM and 1 CPU. That's what. So task is nothing but specifying what we want to achieve or how do we want to run, and then simply execute that particular task. So these are the steps that we're going to do. So let's focus on first, building that Docker image and testing it locally. So let me go back to our code here. That's what we have seen already, right? We have some imports. Then here we load our fine-tuned model. here. This is where we are loading the model, and here we are loading the tokenizer. And you could see I'm taking model from a Hugging Face model hub. Here you could specify any pre-trained model path or your own fine-tuned path if you have put that model on your own account. So if you have watched my previous video, you know that we have pushed our fine-tuned model on my account so that I am able to refer it. And in this video, even irrespective of whether it's a fine-tune or a pre-train, the steps remain the same. Here we have to only put the pre-train thing, right? So, right, if you go to the Hugging Face models, you can choose any model from it, right? There are a lot of BERT-based model we could see. This is one of the popular model called Distill BERT Uncase or BERT Uncase. You can simply copy this name, and that is the name. You can put it here. And then we have seen how to load that particular model and test it on some user input. That's what we saw the demo. What is new here is the Docker file. So we're going to create the Docker image out of this particular code. So let me stop whatever we have running. So I just press Ctrl C and let me clear it. And if you look at the Docker file, each Docker file or a Docker image is built using some base image, which is here. We are building our Docker image from the Python. So overall, Docker file contains the instruction on how to create a Docker image from our local files what we have here. And it also specifies a final command that once we have an image and when we want to run this image as a container, what things we want to run. So these are the steps tells that creating our Docker image, and this final thing says that if we run our image as a Docker container, this is the command it's going to run. Since we have streamlit application, it's going to run a streamlit application. So look at the first command which says that from Python. So this is another Docker based image that we want to build our image on top of this particular image. The next thing is the working directory. We want to set working directory inside that particular image as an app. So whatever we do, now it's happening inside this particular directory. Once we have this directory, we want to copy our requirements and the app file, what you see here on the left side, to the inside the image. So here is the destination, here is the source. Source is our current directory and the requirements file. So current directory here and the requirement file, and it is going inside the image as a destination. And where it is going? It is going inside the app. So we simply copy both of our files inside the image now, and then once this file is available, requirement.txt inside, then we are running a command inside that particular image or a container. So it will run a requirement.txt or pip install requirement so that it will install whatever the requirements or dependencies what we have. So once we build this thing, we're going to expose a 8501 port because that is the port on which our streamlit application runs. And as I mentioned, finally, we're going to run a command streamlit run and the name of the file, which is also present inside the image because we have copied it. So let's run this command. So I kept those command handy, and I can also provide those when I upload the video. Okay, so before that we need to see a prerequisite. Since you have seen we are using the Docker image, or we're going to create the Docker image. So Docker is prerequisite. So on your Windows or whatever operating system you have, the Docker should be installed. Currently, I am using a Docker desktop, and you can see, you can see a search how to install a Docker on your Windows or your local PC. And next thing we want AWS CLI. So CLI is nothing but the command line interface. This is the command line interface which makes it easy to interact with this AWS services. So these are the prerequisite for this particular task what we are going to do. Now, to build a Docker image, we have to use a command docker build, and then -t is the tag. We are calling our image bert streamlit, and then you could see a dot here. Dot determines where is the Docker file located. So where we are currently. Let me see what we have. So we have all this file inside our current directory. let's paste this command here. We want to build a image called bert streamlit, and the context where to get this, so because it need instruction, so those instructions are present in docker file. So we are giving dot is mean current directory, so it's going to look docker file inside the current directory and see it started doing a processing. So you could see the steps it has done, like it copy into the app, then it copy requirement.txt. Now it started running this pip install requirement.txt. Now this might take some time because we want to install 3 dependencies. So I will pause your video and I will restart or resume the video once this particular Docker image is completed. A Docker image which is successfully completed this particular steps, and you can see our installation, the requirement installation took around 400 seconds to get those all the things what we needed. Now we have a Docker image locally, and we can even check. I think command is Docker images. Let's see. Yeah, it's Docker images. You should see the recent image just a minute ago that we have created image called bert streamlit. Now let's run this image locally, and see whether everything works fine as a Docker image. So let me go back to again our instruction. So we have built our bert streamlit image. Now we can run it. There is a docker run command and the name of the image that we want to run, and also the version. Currently the default version will be the latest version, and this thing here, it is a port mapping. So we know that this particular streamlit is going to run inside the container as a 8501 because that is the port we expose, 8501, and that is the port streamlit runs. Now this tells us that from our localhost, wherever I am running this thing, my 8501 port I want to match to the 8501 port inside the container. Now this port could be anything. It could be 8502 also. This is just what we choose, the 8501. So let's run this particular thing. Docker run our port mapping inside the container port. Let's run it. Okay, you could see it has started the Streamlit application because we have given the cmd command as whenever we're going to start that container or that particular image, this is the command it's going to execute. So it has started, and if I go to our localhost 8501, we should see this thing. Now this is actually coming from the Docker image, and the first thing it started is doing the get model because our code application downloads model from the hub, and you can see in the console that it started download or this tokenizer and PyTorch model, which is 400 MB, and it's going to cache it. We have seen this in the previous video, so that we could use that same model from the cache next time. So meanwhile it is downloading, it might take few seconds. Let's go back to the Amazon ECR. So you can search ECR here in the search box of Amazon, and you could see Elastic Container Registry. If I click on it, Elastic Container Registry, this is where we will land. If you already have repositories created, you could see those repositories. So let's create a new repository for us. Let's create repository and we'll keep it private only. Let's give a name to it. So let's give the same name. Whatever the name we have given to the image, we will give the same name to our repository because that repository is nothing but going to store our image. So let's give some image called bert streamlit, and a lot of things we will keep it just whatever the default. We just give the name of our repository and let's create the repository. And you could see our repository got created. This is our repository and this is the URI. Just like locally we gave our image name as the bert streamlit, this is the name we have to refer if you want to use the image, whatever image we're going to upload here. And if I go inside this repository, we should see our all versions or images, but currently there is nothing. Currently there is nothing because we haven't pushed anything. So let's see whether this has downloaded. Seems to be it has downloaded. And this all things are happening inside the Docker container. If I go to my Docker desktop, then I should see some container running. If I click on container, I could see some container running here, which is from the bert streamlit, and it is running on 8501 port, and it started 3 minutes ago. Right, this is the port, and you can see what we have downloaded. You can see inside the Docker image. So it's happening all things inside the Docker image. I can stop it from here also. So before stop, let's go and test that application whether it works same way. So let's type something. Okay, so it does work. So we had our application which we could run locally, but that application now we Dockerize or we containerize instead of saying Dockerize, and that Docker image we have run, and we could see we are getting the same result. The good thing about this is that our containerized application not just only contain our code, it also contain all the dependencies needed to run this code. That is the beauty of containerized application, so that you can take that container or that image and run it anywhere, and it will behave the same way the way it was behaving on your local system, because it has everything that needs to be run. Now go back to our instruction again. So we have our Docker image ready, which is working. Let me stop that container. So once I stop, it will stop, and we should see it is stopping here. Maybe it takes some time. So let's go back to our instruction. We have already created our ECR repository. Now there are certain steps to, first of all, locally we need to log into our AWS ECR, and then we can push our local image to that particular repository. And we don't need to remember these steps. Anyway, I'm going to put this particular file as a part of, whenever I will upload the code. But if you go to our ECR repository, you could see our view push commands. Here you could find those all the commands here, whatever it is required to push particular thing. So if I copy the first command, which is AWS ECR login, let me copy this thing. Okay, this has stopped. Let me clear the screen and let me paste it here. That same command what I got from the ECR, which is nothing but first thing. This is the way it suggests that retrieve an authentication token and authenticate my local Docker client to the ECR registry. That's what it does, this particular command. So let me just run this command. And you see, login succeeded. It authenticated me. How did it authenticated me? Because I already have AWS CLI configured. So if I see AWS, I think configure, I have already put my access key here. If I want to put, I can just put it here again. Here is my secret key, and this is the whatever the default region. So this thing is configured. So whenever you create an AWS account, you will get these 2-3 details, and you could always configure using the same command AWS configure, since I have already configured it. And we see we succeeded login also, and we can follow the same step. Once we succeeded the login, what is the next instruction? It is saying build a Docker image. We have already built our Docker image, so we don't need to do that step now. Once we have image, once we authenticated ourselves, we can tag our local image, which is bert streamlit latest, to this particular value. So we are just like renaming that particular image, and that renaming is nothing but this is our actually repository address. If you see, this is our repository address. So let's copy this thing and let's tag our local image to the name what ECR is expecting. I just click. So you can see now same thing. If I click on, if I see the Docker images, you should see the new image also occurring there. Okay, you could see the latest image, this particular name what we have used, and it is nothing but our same image, which is bert streamlit what we had already, but we just now rename it. Let's follow the instruction. What is the next thing we need to do? Go back to the ECR instruction. This is what we did. Now we can use this command docker push, which will push to our repository, and that is why, since we want to push it, that's why we authenticated ourselves earlier. So let's run that next command, and click. Now see, it started pushing our local image to the ECR repository. Now this might again take some time, because since it's an image, and you could see it's almost more than 3 GB of image. As I mentioned, our Docker image not just only has our code, but it also has all the dependencies needed to run that particular code. So it's going to take few minutes, I think. So I will pause the video, and we will come back to it once it finishes this pushing. And once it finishes, we should be able to see our image occurring here. So let's wait for a while. We can see our image has successfully pushed all the layers of the image, right? And we can go and check now. Let's go to our ECR repository, what we created, and let's refresh here and see whether our image is occurring here or not. Okay, we could see we got our image here, and by default the tag is latest version of the image, and we see some SHA or hash of it. So now once we have an image uploaded to ECR, let's go and do the other stuff what needs to be done to deploy it on a AWS Fargate. Let's go back to our instruction. So till now we have built our Docker image, tested it locally. We also created ECR repository, and we have pushed our image to ECR repository. Now let's create the Elastic Container Service ECS cluster. Let's go back to our serverless computing. Okay, let me go here and just search for ECS. This one, Elastic Container Service. So Elastic Container Service is nothing but scalable container management service, just like what we have Kubernetes. So AWS has both ECS also and the Kubernetes service also. So we're going to use their own managed service, which is there for the highly scalable and the container kind of orchestration or container management system what they have it. So let's go to the ECS, and you could see the list of clusters here. ECS cluster. Let's click on a clusters, and let's say currently we don't have any cluster. Let's create a cluster. And if you could see, there are multiple options, but by default you will see AWS Fargate is selected. So we will click on the next step. Let's give some name to our cluster. Let's call it as a Fargate cluster. Let's call it as a Fargate cluster, right? And we will keep all those things as a default, and let's create it. So cluster is created. That's it. It just giving the name of the cluster, and we got a cluster. And if you could see, there are no tasks or services running here inside that particular cluster. So let's go back to our instruction. Now we have our Elastic Container Service cluster created. Now let's create the task definition. So if you look at what is task definition, so the task definition is required to run our Docker container or Docker image on this particular service, ECS service. And what is that task definition? Task definition is nothing but we tell which image we want to run, which is nothing but our ECR image, that what we want to run. Next thing we specify how much, let's say, RAM we want, how much CPU we want, and that's it. I think that's the only couple of things we do. We don't worry about any individual instances. We only give them what we want as a definition or kind of instruction to the ECS. So let's go here again and go to the task definitions. You could see here. Let's go to task definitions, and let's create a new task definition. Again, you have multiple options, but by default, we want a Fargate definition. Let's click on the next step. Give some name to it. I will call it, let's say, Fargate task. And for a role, we will select whatever the default role is available there. So role are nothing but some permissions required to run our AWS services kind of things, right? Let's keep it almost default here. And another thing we will take is the task memory, how much memory or RAM we want to allocate. So let's allocate 2 GB. Since we have a transformer image which is a model which itself a 400 GB, so let's have at least 2 GB of RAM available. And how much CPU? These are virtual CPU. Let's use only one virtual CPU. Now these two things is going to dictate your cost. So let's have minimal. So now we selected what resources capacity we want. Now the last thing we want, add a container. This is where our image we want to specify. Let's click on add container. Give some name to again this container. I'm just going to call it container one. And here is the image path that we want to copy paste. Let's go to our ECR, right? And let's copy the image URI. I clicked on copy. Let's go to here, paste our thing. Okay, now this all things I will keep it as a default. The next thing is the port mapping. Now we know that our not algorithm, our application run on 8501 port. So we want to specify that particular port here, which is 850, right? So let's go and we want to map wherever it is going to run. We want to map that inside the container port to 8501. Now I think we can keep everything as a default. Let's add this particular thing. Have a look once what we did actually. We just give the name for the task. We selected the default role. Just ignore this warning. And then we specify how much memory we want, how many virtual CPU we want, and finally we added details of our image, which is nothing but we put our name of the or the path of our particular image URL from the ECR. I think all things are good. Let's click on create. So our task is created. Let's view our task definition. And this is what just we created. Now this task is nothing but only instruction. This is the image, this is the RAM, and this is this number of virtual CPU we want. But we need to run this particular task. And where we will run this task? We're going to run that particular task definition on this ECS cluster. So let's execute our task definition. Let's go here. We are already inside that task, Fargate task. Click on action and you could see run task. Let's click on it, run task. Again, you have multiple options. We want to run it as a Fargate type. Then we don't need to do anything. By default, it will select our cluster, Fargate cluster. Why? Because we only have one cluster. If you have multiple cluster, there will be choice. So it selected our ECS cluster that we created in the previous step. Number of tasks, we just want to run one task here, what we have. And then it required a cluster VPC. I think it's virtual private cloud network. I will select the default. Whatever is coming there, we will select those default things. All good? Okay, now let's run the task. You could see one task is running. So we are inside the cluster. By default, we came here and you could see we are on the task tab and there is one task which we want to run. Currently, it is inside the provisioning state, but our desired state is running. So we need to wait for a few seconds or maybe a few minutes to get it running. So I will pause again video and I will resume. Okay, now we can see our task is in a running state. So it's running. Let's click on a task ID, that what we got here. Once I click on task ID, I get all the information of task, which cluster it is running, and which particular task definition it has taken. And you will also see a public IP address. This is the IP address our application, our streamlit application should be running, because that's what we saw when we run our Docker image. So let's go to this application. Let's go to 8501. Now, once you go to 8501, you won't see anything here. You might see an internal server error because though our application is running on 8501, but this particular application is not reachable, or this particular port is not reachable from the outside world. To do that thing, we need to make some changes. You could see it's not running there. We can't access from it here. To make it accessible, this particular 8501 port from the outside world, we need to make some changes. So you could see here ENI, which is nothing but the network interface associated with our task, whatever we have running. So let's click on our network interface link. So this is the interface associated with our task. Now this network interface has a security group you could see here. Let's click on that security group. And inside that security group, there are some rules related to the inbound traffic. So we could see there is one rule for the port 80, but we need to edit those inbound rules and add one more rule. So let's click on add rule here. And yeah, let's say it's a custom TCP rule. What we want to add, we know our port, it's 8501 port. This is the port. We want to make it accessible from the outside world. And there are a couple of options. So this particular 00 whatever it is there, it means that from anywhere from the world, it is this particular port 8501 accessible. So you and all me can access this particular port, not just the AWS infrastructure or AWS VPC what we have here. So let's open it for all the world and click on save rules. Now since the port is open for all the sources, let's go to here and refresh this thing. And you could see our streamlit application is running here, and the first thing it started downloading our model what we required for prediction. So it has downloaded. Let's test it here, and you could see we are on AWS or a cluster or AWS Fargate service, whatever we are using. Let's type the same thing and test it. Yeah, we could see it's a toxic commit, or let's say that was good point. Let's analyze toxic. So this is the way we can take our local streamlit application, containerize that particular application as a Docker image, and then deploy that particular thing as a serverless computing on AWS as a AWS Fargate. You might have found these steps. There are many steps were there, but maybe you are seeing it first time, you might find it overwhelming. But if you do it multiple times, those steps are quite intuitive, right? So first thing, we build our Docker image and test locally. Then we created our ECR repository because this is where we want to push our image. And then we push our local Docker image to that particular ECR repository so that it can be accessible by the other AWS services like our Fargate application. Then we created a ECS cluster, which is nothing but Elastic Container Service, a service provided by AWS to run a containers like Docker container what we are running. And to run something on this cluster, we need to create a task definition. As the name suggests, task definition is nothing but telling the cluster what things we want to run and how much resources we want. So we tell them that this is the image, ECR repository image we want to run. We want 2 GB RAM and we want, let's say, one virtual CPU. And then that task will run. So when that task is running, is nothing but our Docker image is running. And we know that whenever our Docker image is going to run, it's going to run that streamlit application because that's what the starting command what we have given to our Docker thing. And the one last thing, that though we are running our application there, it's not accessible from the outside world. So we need to change some network setting and make sure the 8501 port is accessible from all the sources outside of AWS. And that's what we did. And this is the way we have a containerized transformer model doing prediction on a Fargate, which can be scaled for any number of applications because scaling will be taken care by AWS Fargate itself, and it is going to cost you whatever the time you're going to use it. If you found this video useful, please do subscribe to my channel. I have a couple of videos on my channels related to the multiple topics. I think you could see there are related to the conversational AI or building custom name entity recognition, or even recently I uploaded one video related to how did I got my first freelancing job. And there are many, even the GPT-3 or aspect-based sentiment analysis. So please do subscribe to my channel and let me know into the comment if you have any doubt or do you have any suggestions for me to, for the next video. Thank you.